Let's today practice several questions about the absolute value. Recall that the absolute value of A equals A itself if A is positive or equal to 0. Negative A if A is negative. Okay? That's it. Another way, if we can express this definition, if A itself may have several values, whether positive, 0, negative. If it is positive and 0, A will remain the same. If it is negative, A will be different. We will have the negative A or negative value. That's it. If we have 4, the absolute value of 4, it is equal, because here 4 is positive, then it is the same number. The absolute value of 0, because it is 0, we have the same number. The absolute value of negative 4 is equal to the negative of what is inside, which is negative 4. Then it should be positive. It is important to know that the absolute value of any number, we would like to know whether this value here is positive or negative or 0. We would like to know. How can we, for example, if we have an expression x plus 3, the absolute value of x plus 3, how do we know that this value is positive, negative, or 0? We can know only one thing. We can know only one fact, that we take the expression x plus 3 and see what is the value does make this expression equal to 0. Of course, it is minus 3. So in the real number line, because if we put here minus 3 plus 3, it should be 0. If in the real number line, or in the number line, 1, 2, 3, minus 1, minus 2, minus 3, minus 4. At this value here, x plus 3 equals to 0. At value of x equals minus 3, we have 0. So this value separates the whole thing. We take values in this area and check, and we take values at this area and check how the expression x plus 3 is, whether if it is positive, negative, or 0. We would like to check. So if we take values, let's say greater than 3, so minus 2 here is greater than 3. Let's say minus 2. X plus 3 should be minus 2 plus 3. The answer is 1, so it is here positive. What about values in this area? So we will take minus 4. So minus 4 here, minus 4 plus 3. The answer is minus 1. So the expression x plus 3 is negative. Okay? The expression x plus 3 is positive when values in this range, and x plus 3 is negative when values are in this range. So Keep this in mind, because when we are solving the questions regarding the absolute value, we have to consider these things. Let's try some exercises to assess our understanding about the absolute value. If I ask you, write without the absolute value, it is similar to simplify. Okay, let's have, for example, negative of the absolute value of negative 5. Negative of the absolute value of negative 5. How to answer that? It is equal to, this negative will remain the same, negative. And since we have a negative value inside the absolute value, so we will have the negative of the value, right? The negative of the value. Okay, what is the negative of the value? We will see. Of course, this will remain here the same. Negative multiplied in negative should be positive, so it is 5, positive 5. So the final answer is negative 5. Okay, another question. The negative of the absolute value of negative 4, the overall square. The answer of this question should be, this negative will remain the same because it is outside. We will open parentheses and see what's going on. Okay, of course, the expression here, the absolute value of negative 4, the overall is squared, so here it is squared. What about the absolute value of negative 4? It is the negative of what is inside. Okay, then we will write this again, so this negative will come here, and the negative of negative 4 is positive 4, and this is square will come here, so it is the answer negative of 16, which is negative 16. What if I ask you the absolute value of 3 multiplied in the absolute value of negative 4? Since this is positive, 3 is positive, so it will remain the same, so it should be here 3 multiplied in minus 4, the absolute value of minus 4, which is 4, then the answer is 12. Another question is that the absolute value of 3 minus the absolute value of negative 7. The absolute value of 3 is 3. This negative will remain here the same. Then the absolute value of negative 7 is 7. So the answer should be minus 4. If I tell you the absolute value of, for example, pi square plus 10, the answer should be, because this is squared and this means it is positive. We don't expect, when squaring a number, a negative number, so always this is positive, and when you add a positive number to a positive number, so the whole expression always positive, so this expression will remain the same. It is pi square plus 10. What if I ask you the absolute value of pi square minus 10? Okay, we know this is positive, and however this value here is negative, so if this value is greater than 10, let's say for example 11 minus 10, the expression is positive. If it is less than 10, let's say 9 minus 10, the expression will be negative. I mean by the expression, I mean by square minus 10 is the expression. Okay, however, we don't know. We know previously that we know that pi is approximately 22 over 7, right? So if we say 22 over 7 squared, this number should be 484 over 49. So pi square minus 10 is approximated as 484 over 49 minus 10. To check now, we will simplify this. Multiply here, of course, by 49 over 49 to see what is this. So it is 484 over 49 minus 490 49. So this expression is written as 484 minus 490 over 49. Of course, 484 minus 49 is negative. Therefore, our expression, which is pi square minus 10, is negative. So the answer of the absolute value of pi square minus 10 equals to the negative of what is inside. So negative of pi square minus 10. Then it is written as 10 minus pi square. By the way, this one also, this can be written as minus pi square plus 10. It is okay. This is correct. This is correct. Now suppose I ask you to write without the absolute value, or I say simplify. Okay, this is the question, the absolute value of x plus 3. We don't know what is this expression equals to, whether if it is positive or 0 or negative. How can we answer this question unless we know what is inside here? We have to know whether if it is positive, 0 or negative. Why is that? Because the absolute value definition depends on that. The absolute value of A is remaining the same, what is inside, if A is greater than or equal to 0. That is, if it is positive or equal to 0. Okay? And it is the negative of what is inside when A is negative, or A is less than 0. So the negative A when A is less than 0, and A itself when A is positive or equal to 0. So we would like to know whether this expression x plus 3 is positive or 0 or negative. You cannot say that x plus 3 is always positive or 0 or negative. X plus 3 can take different values because we have x here. X can take any number in the real number line, can take values from here up to here. So x plus 3 change, sometimes positive, sometimes 0, sometimes negative. So what are the situations in which x plus 3 is positive, 0, negative. What are the situations where x plus 3 we have positive expression, and x plus 3 we have 0 expression, and x plus 3 we have negative expression? We would like to know exactly what these values that make this expression positive or 0 or negative. Again, back to our question, we have to know in which cases we have positive or 0 or negative of this expression x plus 3. How is that? The first and easy way, okay, when does x plus 3 equal to 0? We know when x equals minus 3, because minus 3 plus 3 will lead to 0. So we know what is the value that makes x plus 3 equal to 0. Okay, so we have here the number line from 0, 1, 2, 3, negative 1, negative 2, negative 3, negative 4. So at x equals minus 3 equals, so it is closed here, at x equals minus 3, the expression x plus 3 equals to 0. Okay, again we would like to know what are the values that make x plus 3 positive, 0, negative. Okay, we know the value that makes x plus 3 equal to 0 is what? It is x at x equals minus 3. Okay, how to determine that? We take values of x, and we have the expression x plus 3, right? We know that at x equals minus 3, the expression x plus 3 equal to 0. Okay, now let's take values in this area. Take values to the right of at x of minus 3. Okay, any value you like. If we take x, for example, minus 1, let's take x minus 1. Okay, when x equals to minus 1, this expression equals minus 1 plus 3, which is equal to 2. Then the answer is positive. Okay, let's now take values to the left of minus 3 at this area. Okay, take any value. Take any value you like. So if we take negative 4, then the expression x plus 3 equals to minus 4 plus 3, which is minus 1. So it is a negative value. Now we know when is x plus 3 positive, when it is 0, when it is negative. Okay, now we can answer our question. To answer our question, the absolute value of x plus 3, it is equal to two different values. It is what is inside the same remain here, x plus 3, when this expression is positive or equal to 0. Now, when does this expression x plus 3 equals positive and 0? It is when x is equal to negative 3 up to infinity, this area. Okay, x plus 3 is positive or equal to 0 when x is between negative 3 closed, because when it is closed at minus 3 we have 0. So from negative 3 closed up to infinity. Also, when does x plus 3 equals to negative? So you are in this area. Of course, minus 3 is not included. You go in this area. So in this area, we say the expression x plus 3 is negative. It is from negative infinity up to minus 3 open. Okay, now this expression will remain the same when x between negative 3 closed up to infinity open, and will be the negative of what is inside, so minus x minus 3 when x is from negative infinity up to negative 3. And of course you can write this in other way in set builder notation. It is when x is greater than or equal to negative 3. Here this can be written when x is less than minus